October 1943, a remote jungle island in the Pacific. Humid air clings to every surface, dripping from palm fronds. The distant crash of surf mingles with the rhythmic hammering of steel, and the low groan of timber being lifted into place. Hidden bays reveal a half-finished harbor. Skeletal cranes rise above dense foliage, while partially assembled ships float in muddy waters, their hulls obscured by camouflage netting. A German reconnaissance captain crouches in the undergrowth, binoculars pressed to his eyes. He scans the chaotic precision below. Soldiers and laborers moving with purpose. Ropes swinging, planks lowering, engines being hoisted into hulls. The sheer scale is almost incomprehensible. Reports had underestimated the Americans' ability to construct shipyards so far from home. He notes the smoke from makeshift forges, the tents housing engineers, and the constant motion of workers under the oppressive sun. In that moment, the captain realizes this is more than a base. It is a feat of audacity and engineering, an entire naval facility, carved from jungle and mud, rising in weeks where the enemy assumed only isolation existed. The Americans are rewriting the rules of the Pacific War. By late 1942, the Pacific theater had reached a critical juncture. The Japanese Empire, flush with victories across Southeast Asia, controlled vast stretches of ocean and island chains, from the Philippines to the Solomon Islands. Their naval and air dominance threatened Allied supply lines and made even modest offensive operations perilous. For the United States, the challenge was not only defeating entrenched forces, but also establishing forward bases to project power across thousands of miles of ocean. Every island mattered, and every harbor could become a lifeline. Following the disaster at the Battle of the Coral Sea in May 1942 and the subsequent loss at Guadalcanal's initial stages, American strategists understood that conventional naval bases in controlled territories were insufficient. The solution was audacious: construct functional shipyards, repair docks, and supply depots on islands previously assumed inaccessible or hostile. Engineers, Seabees, and military labor units were deployed under extreme conditions: thick jungle, tropical diseases, torrential rains, and the constant threat of Japanese reconnaissance or artillery strikes. The United States Navy's construction battalions, better known as Seabees, became the spearhead of this initiative. Trained in both combat and construction, these units were tasked with building infrastructure capable of supporting battleships, destroyers, and auxiliary vessels. They worked alongside Army engineers and civilian contractors, improvising techniques to deal with coral, mud, and shifting tidal patterns. Timber was felled, rock blasted, and steel frameworks erected with astonishing speed. Meanwhile, intelligence reports from the German Kriegsmarine and the Japanese combined fleet underestimated these capabilities. Axis planners believed that logistical challenges, disease, and supply shortages would make large-scale shipbuilding in forward islands impossible. Reconnaissance missions over islands in the Solomons and New Hebrides often returned astonished messages. American workers operating under canvas shelters were repairing hulls, assembling engines, and installing cranes with a speed that defied expectation. Radio intercepts captured Japanese officers expressing disbelief at the sudden appearance of functional naval facilities in what had previously been considered neutral, uninhabitable terrain. The significance of these forward shipyards was multifaceted. From a strategic perspective, they allowed the Allies to maintain continuous pressure on Japanese supply lines and to repair vessels without sending them hundreds of miles back to Australia or the U.S. mainland. This reduced downtime and increased the operational tempo of the Pacific Fleet. From a technological perspective, the ability to assemble complex machinery in remote locations demonstrated not only logistical prowess, but also ingenuity in engineering and improvisation. Temporary slipways, modular hull construction, and makeshift cranes allowed massive ships to be repaired or even partially constructed in conditions that previously would have been considered impossible. The human element was equally remarkable. Men from different branches, Navy, Army, and civilian specialists, worked side by side, often living in tents, mud, and sweat-soaked uniforms for weeks. Tropical diseases, venomous wildlife, and unpredictable weather were constant hazards. Yet the crews maintained discipline, morale, and precision, driven by the knowledge that their work directly affected the broader outcome of the war. Letters home describe the tension and exhaustion, but also the pride in witnessing engineering feats emerge from seemingly impenetrable jungles. On the enemy side, German naval officers monitoring Allied operations faced a growing sense of incredulity. Reports filtered back from intelligence networks in the Pacific that American shipyards were not only operational, but also expanding. The Germans, accustomed to conventional naval doctrine and supply chains, struggled to comprehend the speed and scale of these projects. In Berlin, Kriegsmarine analysts debated the plausibility of constructing fully operational docks, fuel depots, and repair facilities in the heart of islands, surrounded by hostile waters and jungles. Japanese forces, too, were caught off guard. Attempts to disrupt construction through air raids and coastal bombardment met with limited success. Camouflage, dispersion of assets, and the ingenuity of Seabees meant that even direct attacks often caused minimal delay. A shipyard under construction could see cranes repaired overnight, hulls patched, and engines operational within days, leaving Axis planners scrambling to reassess their assumptions. The combination of audacious planning, engineering innovation, and human endurance transformed isolated islands into forward operating bases. These developments not only bolstered the Pacific Fleet, but also sent a psychological message. American industrial capacity and adaptability could manifest anywhere, even deep within enemy-dominated territories. For German captains observing from afar, these impossible shipyards were proof that the United States could defy expectations on multiple fronts, changing the dynamics of naval warfare in the Pacific. The stage was set for the first encounters where these newly constructed facilities would directly influence combat operations, giving the Allies the ability to strike with unprecedented reach and efficiency. This extraordinary logistical achievement would soon collide with the tactical realities of Japanese defenses and the keen eyes of enemy observers. By early 1943, the network of American-built shipyards and repair facilities across the Pacific had expanded rapidly. Key islands in the Solomons, New Hebrides, and New Guinea were transformed from dense, uncharted jungles into functional bases. Wooden piers, coral-reinforced docks, and modular repair sheds rose amid palm trees, often camouflaged to evade enemy reconnaissance. Seabees and engineers coordinated shipments of prefabricated steel, timber, and machinery via convoys protected by destroyers and PT boats. Every delivered crate contained components vital for constructing dry docks, cranes, or even floating repair barges. The logistical complexity was staggering. Supply chains stretched thousands of miles from American ports on the West Coast and Australia to remote Pacific islands. Engineers had to account for tidal fluctuations, coral reefs, and unpredictable storms, all while maintaining secrecy from Japanese air and naval patrols. Transporting heavy machinery inland often required improvisation. Soldiers and Seabees built temporary roads, lifted engines using block and tackle systems, and used amphibious vehicles to move critical components across coral beaches. German observers, relying on intercepted radio communications and Japanese intelligence, continued to express astonishment. Kriegsmarine reports detailed American ingenuity, noting that docks and shipyards appeared overnight, and that vessels requiring major repairs returned to service within days. In naval planning offices in Berlin, analysts debated the implications. The traditional European model assumed that shipyards were immovable assets, heavily fortified and located near industrial centers. The American approach, however, demonstrated mobility, flexibility, and rapid construction, qualities that German naval doctrine had not accounted for. Japanese commanders also recognized the strategic threat. These forward shipyards allowed the U.S. Navy to maintain operational pressure across the South Pacific. Battleships could now be serviced close to front lines. Carriers could launch repeated sorties, and transport vessels maintained the flow of supplies to Allied troops on contested islands. The combination of repair facilities and storage depots meant that American forces could operate for extended periods without retreating to distant ports, a capability the Japanese had previously considered impossible. The human stories behind these shipyards are equally compelling. Seabees and Army engineers endured weeks of relentless heat, monsoon rains, and malaria outbreaks. Yet discipline and ingenuity prevailed. Men constructed dry docks by hand, using sandbags and wooden scaffolding to redirect tidal flows. Diesel engines, torpedo tubes, and artillery mounts were repaired on-site under the shadow of coconut palms. Observers noted the relentless rhythm, crews working at dawn, breaking for brief meals, and continuing late into the tropical night under improvised lighting. Fatigue was constant, but so was morale, fueled by the tangible results of their labor. A battleship refloated, a destroyer repaired, a crane operational. From a technological standpoint, the construction of shipyards in jungle islands represented a radical departure from conventional naval logistics. Prefabricated structures, modular assembly, and adaptable designs allowed the Americans to bypass the limitations of terrain. Floating dry docks could be towed into position, anchored, and immediately put into use. Cranes could be assembled on-site with minimal infrastructure. Communication systems, water supply, and power generation were improvised but functional, enabling a full spectrum of ship maintenance activities. German and Japanese intelligence struggled to understand the scale of this achievement. Reports highlighted the speed of construction, the apparent disregard for environmental challenges, and the precision with which these isolated shipyards functioned. German naval officers marveled at the adaptability, describing the facilities as like seeing a city rise from the jungle overnight. Such observations sowed a mixture of awe and concern within Axis command circles, raising questions about how future operations could contend with American logistical superiority. The strategic implications were profound. Forward shipyards enabled sustained Allied offensives across previously inaccessible areas. Ships could remain on station for weeks, refueling, repairing, and redeploying without the vulnerability of long transits to distant bases. The ability to project naval power from islands once deemed unserviceable gave American commanders unprecedented operational flexibility, altering the dynamics of the Pacific campaign. As these facilities became fully operational, the stage was set for the first major encounters where the combination of tactical skill, engineering ingenuity, and industrial capacity would confront entrenched Japanese positions. The German captains monitoring these developments could only speculate on the potential outcomes, but the evidence was clear. The Americans had redefined what was possible in maritime logistics, turning isolated jungle islands into strategic anchors for their Pacific campaign. The men who built these shipyards were the unsung heroes of the Pacific campaign. Seabees, often drawn from civilian trades, carpenters, machinists, electricians, adapted their skills to the harsh realities of jungle warfare. They labored under blistering sun, through torrential rains, and amid swarms of mosquitoes. Each beam lifted, each crane assembled, required both ingenuity and brute force. Illness and exhaustion were constant threats. Yet, morale persisted, fueled by camaraderie and the knowledge that every repaired ship contributed directly to the survival of frontline soldiers and sailors. Letters home described the bizarre blend of manual labor and military urgency, of constructing entire operational ports in places where only weeks before there had been nothing but dense jungle. These men lived a paradox of war. combat without bullets, victory without direct engagement. Yet their work influenced the course of entire battles. From a tactical standpoint, forward shipyards transformed naval operations. American commanders could repair cruisers and destroyers close to contested islands, reducing downtime and maintaining continuous pressure on Japanese positions. This logistical advantage allowed for more frequent sorties, sustained bombardments, and rapid reinforcement of isolated garrisons. In island campaigns such as Bougainville and Tarawa, the presence of on-site repair facilities meant that damaged ships could return to service in days rather than weeks. German naval analysts noted this capability with alarm. They had assumed that the Americans, operating far from industrial centers, would struggle to maintain a high operational tempo. These forward bases rendered that assumption obsolete, giving the U.S. Navy an unprecedented edge in operational flexibility. The technology behind these shipyards was deceptively simple yet revolutionary in execution. Prefabricated steel and timber structures allowed rapid assembly in hostile environments. Floating dry docks could be anchored and immediately used to lift vessels for repair. Mobile cranes and modular workshops provided the tools necessary to handle engines, hull plating, and artillery systems on site. Engineers implemented innovative solutions to power and water shortages, creating temporary electrical grids and desalination systems from available resources. These adaptations allowed a functional shipyard to exist, where, according to traditional European naval doctrine, none should have been possible. The speed and efficiency of these installations shocked Axis observers, demonstrating that American industrial capacity, when combined with ingenuity, could overcome any natural barrier. Command structures overseeing these projects were tightly coordinated yet decentralized. Officers and senior Seabees empowered smaller teams to make immediate decisions on construction methods, resource allocation, and problem solving. This approach minimized delays and leveraged the specialized skills of every team member. Leadership emphasized discipline without rigid hierarchy, fostering initiative and rapid response to unforeseen challenges, whether it was a supply shortage, mechanical failure, or sudden tropical storm. German intelligence reports expressed astonishment at the organizational effectiveness. These bases operated like miniature cities, entirely self-sufficient, in some cases miles from the nearest traditional port. The combination of clear directives, empowered teams, and relentless oversight allowed American forces to exploit the logistical frontier in ways Axis powers had not anticipated. German captains, receiving intelligence from intercepted communications and captured reconnaissance reports, struggled to comprehend the scale and audacity of American shipyards in the Pacific jungles. They had expected supply lines to be overstretched, maintenance delayed, and forward operations limited by distance and terrain. Yet photographs and first-hand accounts revealed functioning dry docks, warehouses stocked with spare parts, and docks full of repair crews working under canvas shelters and hastily constructed hangars. The speed at which these bases became operational baffled them. One report from a Kriegsmarine officer noted, "It is as if the Americans summon ports from the earth itself, defying logic and distance." This perception influenced German strategic calculations, reinforcing the idea that Allied forces could maintain pressure in remote theaters far longer than previously thought. The psychological impact of these shipyards on both American and Axis forces was profound. For American sailors, knowing that damaged ships could be repaired nearby bolstered confidence and operational aggressiveness. Commanders could plan missions with reduced fear of losing assets permanently. For Axis sailors and observers, the knowledge that the Americans could maintain uninterrupted naval presence deep in the Pacific instilled unease and a sense of inevitability. The perception of unstoppable logistical support undermined morale and contributed to cautious decision-making, slowing offensive initiatives. The visible, tangible presence of functioning shipyards symbolized American industrial might in miniature form, proof that no natural barrier, jungle, or island chain could halt their war effort. Constructing shipyards in dense jungle islands presented unparalleled environmental challenges. Heavy rainfall caused erosion and flooding, while tropical storms threatened to undo days of labor. Swamps and mangroves required innovative foundation solutions, often involving pilings driven into marshy soil or floating pontoons to support cranes and workshops. Disease, malaria, dengue, and dysentery was constant, and supply lines had to account for the transport of potable water, food, and fuel. Despite these obstacles, Americans leveraged local terrain intelligently, using natural bays as sheltered anchorages, elevating workshops above flood zones, and clearing only what was necessary to maintain operational security. The result was a remarkable fusion of engineering skill and environmental adaptation, transforming hostile landscapes into fully functioning industrial sites. Strategically, the presence of these shipyards altered the dynamics of Pacific warfare. They enabled sustained naval campaigns against entrenched Japanese positions by ensuring vessels could return to combat-ready status quickly. Islands that had once been isolated points of contention became hubs of repair, supply, and reinforcement. Commanders could deploy combined naval and ground operations with increased confidence, knowing that damaged ships would not be stranded. The flexibility allowed by these bases accelerated the island-hopping campaign, reduced attrition, and amplified American operational reach. Axis planners struggled to counteract this advantage. Air attacks on these sites were difficult. The jungle provided natural concealment, and rapid reconstruction rendered strikes only temporarily effective. The success of these forward shipyards influenced post-war naval doctrine and engineering. Lessons learned from rapid construction, modular design, and decentralized command informed Cold War military planning. Prefabricated docks and temporary repair facilities became standard practice, and the concept of self-sustaining forward bases shaped naval logistics for decades. Captured reports and photographs circulated among Allied planners, emphasizing that adaptability and speed could often outweigh numerical or technological superiority. For historians, these shipyards illustrate the intersection of human ingenuity, industrial capacity, and military necessity, a combination that redefined naval operations in the Pacific. November 1943. The island of Bougainville, part of the northern Solomon chain, lay shrouded in thick jungle and mist, its beaches pounded by relentless waves. From the vantage of high cliffs, American reconnaissance observed Japanese positions, camouflaged beneath palm fronds and bamboo scaffolds. The morning air was heavy with humidity, and the distant rumble of artillery from neighboring islands underscored the ever-present threat. Amid this, the U.S. Navy's newly established forward shipyard at Cape Torokina buzzed with activity. Cranes lifted damaged destroyers from shallow bays, hulls patched, engines overhauled, and weapons recalibrated, all under the canopy of tropical foliage that shielded operations from aerial reconnaissance. On November the 1st, the 3rd Marine Division prepared to land. Troop transports glided through coral reefs with precision, while destroyers and cruisers, repaired and refitted just days before at the Jungle Shipyard, took station offshore. The shipyard's impact was immediate. Vessels returned to duty in record time, some with engines rebuilt in a matter of days, artillery realigned, and communications equipment recalibrated. For the first wave of Marines, the presence of this forward facility meant that naval support could be continuous. Unlike previous campaigns where damaged ships had to return to distant Pearl Harbor or Espiritu Santo, here repairs were immediate and local. Japanese defenders, expecting attrition and exhaustion to thin the American forces, were blindsided. Radar and signal intelligence indicated an unusually high number of operational vessels in the landing area. Captains reported, "Our calculations had assumed at least 2 weeks before they could rotate damaged ships. The Americans appear to conjure reinforcements from the jungle itself." The combination of repaired destroyers providing bombardment, minesweepers clearing coral channels, And supply vessels arriving fully stocked created a tactical environment the Japanese had neither anticipated nor prepared for. By mid-morning, Marines had established a beachhead. Artillery from repaired cruisers pounded inland fortifications, while supply barges, also serviced at the forward shipyard, delivered ammunition, rations, and medical units directly onto the sand. Engineers and Seabees, working alongside Marines, expanded the temporary docks, allowing larger landing craft to unload tanks and artillery faster than anticipated. The speed of this logistical flow directly translated into combat effectiveness. Marines could sustain offensive momentum, and commanders had the flexibility to rotate units without fear of a logistical collapse. Meanwhile, air reconnaissance confirmed Japanese confusion. Intercepted radio messages revealed disbelief. Supply lines appeared intact, frontline ships operational, and every American advance reinforced by additional firepower. From the enemy's perspective, the shipyards seemed almost preternatural, turning remote, inhospitable islands into fully functioning industrial hubs. One Japanese intelligence officer wrote in a report, "They do not merely land, they arrive prepared to continue fighting without pause. It is as though the ocean itself bends to their will." Late afternoon brought the first significant engagement with Japanese armor attempting to counterattack. U.S. naval gunfire, originating from vessels repaired at the Jungle Shipyard, proved decisive. Destroyers, previously damaged during earlier skirmishes in the Solomons, fired accurately despite prior impairments, neutralizing enemy tanks and artillery positions with precision. The turnaround time from damage to redeployment, sometimes less than a week, meant that American ships could maintain sustained pressure on Japanese positions without rotating out for repairs. This operational continuity directly influenced the tempo of the battle, forcing Japanese forces into defensive postures they had hoped to delay or avoid entirely. By evening, the Marines had secured key high ground overlooking the landing zones. The Jungle Shipyard, invisible to the enemy from the air, had indirectly dictated the outcome of the day's engagements. Commanders on both sides recognized that the ability to maintain forward operational readiness, not sheer firepower alone, was decisive. This was the first battle in the Solomons where local repair and refit capabilities allowed Americans to project overwhelming force far from established naval bases. The forward shipyard's role would continue, over the coming weeks, repairing cruisers, destroyers, and transport vessels damaged in subsequent skirmishes, while engineers expanded temporary dry docks to accommodate larger vessels. Each repaired ship restored combat potential faster than Japanese planners could anticipate, steadily tipping the operational balance. From the perspective of U.S. planners, Bougainville became proof of concept. With ingenuity and speed, the Pacific theater could be dominated not only by men and weapons, but by logistics adapted to terrain. For the Japanese, disbelief remained, as forward shipyards turned what was expected to be a grueling, attrition-heavy campaign into a sequence of rapid, coordinated assaults that continually overwhelmed defenders. As night fell, lanterns flickered in the jungle encampments, illuminating cranes, scaffolding, and hulls undergoing repair. The war machine operated quietly beneath the canopy, unseen but undeniably powerful. Each ship restored, each engine rebuilt, each gun recalibrated brought the Americans closer to securing the island chain and demonstrated the decisive interplay between engineering, logistics, and combat operations. The stage was now set for the next wave of assaults, where the full advantage of these forward shipyards would manifest in even larger naval engagements and the eventual isolation of Japanese strongholds across the Solomons. Early December 1943. Bougainville's beaches, still scarred from the initial landings, now hummed with constant activity. The forward shipyard had expanded, adding makeshift repair piers and camouflaged storage for fuel and ammunition. A rain-soaked morning revealed Marines trudging through mud, hauling supplies freshly off barges repaired at the jungle docks. From the shoreline, the roar of artillery and machine guns echoed through the dense foliage, a reminder that the battle was far from over. Yet every operational vessel offshore, destroyers, cruisers, and landing ships, stood ready, their hulls straight, guns aligned, engines tested and repaired on site. The speed and efficiency of these repairs provided a critical advantage. On December 4th, a major counterattack by Japanese forces aimed to disrupt the American beachhead. Infantry, supported by light tanks and mortars, pressed through narrow jungle trails toward the landing zones. From offshore, destroyers, many returned from combat only days prior after repairs at the shipyard, delivered precise fire support. Coastal artillery, realigned and recalibrated in the jungle docks, neutralized enemy positions that might have otherwise pinned the Marines. Intelligence intercepted by American units indicated the Japanese were struggling to anticipate the timing and scale of naval firepower, a direct result of ships returning to action faster than ever expected. Aerial observers reported American transports unloading additional artillery pieces and tanks with unprecedented efficiency. Engineers had improvised ramps and temporary docks that allowed vessels to offload heavier equipment directly onto cleared beach sectors. These measures ensured that combat units maintained momentum, countering Japanese infiltration and holding forward positions. Even small craft, used for reconnaissance and patrol, were serviced at the jungle shipyard, keeping intelligence and communications uninterrupted. By midday, Japanese forces attempted to concentrate armor against the Marines' flank. Here, the forward shipyard's impact became unmistakable. Destroyers, patched from previous engagements, unleashed rapid salvos, while cruisers, their hulls restored and reinforced, provided continuous bombardment from offshore. Tanks and artillery pieces, previously damaged or low on ammunition, had been repaired or resupplied within days, now serving at full capacity. The combined effect of sustained naval fire and freshly reinforced Marine positions disrupted enemy formations, forcing withdrawal under heavy casualties. Forward observers noted a striking contrast. Where once the Americans had risked attrition due to extended supply lines, the presence of the shipyard allowed them to operate in near-continuous cycles of combat and repair. Command reports highlighted the psychological impact. Marines fought with renewed confidence, knowing that any damaged vessel or weapon could be returned to service in minimal time, while Japanese planners faced mounting uncertainty. The afternoon sun pierced the jungle canopy, glinting off repaired guns and freshly painted hulls. Engineers and Seabees worked tirelessly to maintain this tempo, even improvising repairs under intermittent enemy artillery fire. One naval officer remarked in his journal, "We are fighting, yes, but we are also building the battlefield itself. Each repaired ship, each restored gun, each barrel of fuel delivered strengthens the line without pause." These logistical feats ensured that Americans could sustain operations, rotate units, and launch coordinated assaults with precision. By December 6th, the island's inland roads and jungle trails were dotted with American vehicles moving artillery, medical supplies, and engineers to forward positions. Supply chains, previously vulnerable, were now fortified by on-site repair facilities. Tanks damaged in reconnaissance missions returned to action within days, while artillery pieces recalibrated at the docks pounded Japanese defensive lines. Marines on the front lines reported unprecedented reliability from their supporting units, a morale boost that directly influenced engagement outcomes. Japanese forces, facing relentless bombardment and a steady influx of repaired American vessels, began to realize the operational advantage the shipyards conferred. Captains documented frustration in coded messages. Their vessels, previously out of action, returned to fight as though the ocean itself mends them. "We cannot anticipate when or where the next strike will come. The rapid turnaround, of both small and capital ships had effectively compressed the repair and reinforcement timeline by more than half compared to prior campaigns. By nightfall, the Japanese counterattack had failed. Marines held strategic hills and secured key beachheads, while the forward shipyard, still operational under torchlight and lanterns, continued repairs to prepare for the next day's engagements. Supply barges, guided by engineers, shuttled ammunition and medical units directly from dock to combat units. The combination of quick repairs, immediate redeployment, and efficient supply distribution had created a sustained operational cycle, leaving Japanese forces unable to recover or reorganize. December 7th and 8th followed the same pattern. Repeated assaults neutralized by the seamless integration of combat and repair. Forward shipyard operations allowed American forces to maintain the initiative at every turn. Every damaged cruiser or destroyer returned from the jungle docks was a testament to ingenuity and foresight, a local solution to logistical constraints that, until then, had limited naval projection in the Pacific. As the island campaign drew to a close, reports emphasized that the forward shipyard had been as decisive as any artillery barrage or amphibious landing. Naval officers noted that the ability to restore ships and weapons on site had changed the tempo of warfare in the Solomons. The concept of maintaining operational readiness through local repair facilities would later inform broader Pacific strategies, demonstrating that engineering and logistics were as pivotal as strategy and combat skill. With Japanese resistance effectively neutralized, Bougainville was secured. Marines set up defensive positions, artillery remained in place, and engineers continued work on the shipyard, ensuring vessels could support operations on nearby islands. The forward shipyard had proven its strategic worth. A single logistical innovation concealed beneath the jungle canopy had amplified combat effectiveness, maintained operational momentum, and reshaped the course of the campaign. The successful integration of repair and frontline operations set the stage for the final Allied push in the northern Solomons, and the eventual isolation of Japanese strongholds throughout the Pacific. By early 1944, Bougainville's beaches were quiet compared to the intense clashes of the previous months, but the remnants of combat were everywhere. Burned-out vehicles lay scattered along jungle trails, craters pocked the shoreline, and the skeletal remains of hastily constructed fortifications bore witness to the ferocity of the Japanese counterattacks. Yet amid the destruction, American forces stood in control, their operational capacity significantly enhanced by the forward shipyard. Reports highlighted that vessels previously deemed combat ineffective returned to duty within days, rather than weeks, a decisive factor in maintaining pressure on enemy positions. The human cost of the campaign was sobering. Marine casualty reports listed over 1,500 wounded and nearly 400 killed in action during the intense December counterattacks. Japanese losses were far higher, with estimates ranging from 3,000 to 5,000 dead and wounded, compounded by desertions and surrenders. Intelligence indicated that the failure to neutralize the American shipyard had been a critical miscalculation. Captured Japanese officers later confirmed that they had underestimated the speed at which Americans could repair and redeploy vessels. The psychological impact was equally significant. Marines reported heightened morale, reassured by the knowledge that damaged equipment and ships would not remain sidelined during crucial engagements. Beyond the immediate battlefield, the strategic consequences of the forward shipyard were profound. Bougainville became a model for integrating engineering solutions directly into operational planning. High-level Navy and Marine Corps evaluations emphasized the efficiency gains achieved. Ships that would have required weeks in rear area bases were restored in days. Artillery and tanks returned to frontline service without long delays, and supply chains remained uninterrupted. Official Navy dispatches noted The establishment of a functional repair facility at the front allowed us to maintain continuous pressure on enemy forces, a factor decisive in the rapid stabilization of the Bougainville beachhead. Seabees. The Navy's construction battalions received particular recognition. Their improvisational ingenuity, constructing floating docks, camouflaged repair piers, and reinforced supply depots, ensured that operations could continue despite the dense jungle, torrential rains, and intermittent enemy fire. These efforts also reduced logistical strain on rear area bases, freeing resources for broader campaigns across the northern Solomons. Reports later detailed that the Seabees repaired over 45 vessels, ranging from small patrol craft to larger destroyers, alongside dozens of artillery pieces and tanks, all within a matter of weeks. The success of the forward shipyard influenced post-campaign evaluations on Pacific warfare. Military strategists concluded that forward repair and maintenance facilities could effectively compress operational cycles, reduce attrition, and maintain combat momentum. Intelligence assessments noted that the Japanese had repeatedly failed to anticipate the rapid turnaround of American assets, a factor that contributed directly to their inability to mount sustained counteroffensives. Operational reports described a new model of warfare, one in which engineering and logistics became as critical to victory as firepower and strategy. Civilian observations also highlighted the broader impact. Local populations on Bougainville, though limited in number, noted the constant movement of repaired vessels and the disciplined organization of repair teams. Photographs captured the juxtaposition of jungle wilderness with repaired warships, artillery, and vehicles being prepared for immediate redeployment. These images later served as historical evidence of the innovative measures employed by the Americans, reinforcing the narrative that logistics and engineering could decisively shape combat outcomes. By mid-1944, Bougainville had become a forward base of operations for subsequent island campaigns. Repaired ships enabled continuous naval bombardment of Japanese positions on surrounding islands, allowing Marines and Army units to advance with minimal disruption. The tactical advantage provided by the shipyard extended beyond Bougainville itself. It enabled coordinated assaults across the northern Solomons, accelerated the isolation of Rabaul, and contributed to the broader Allied strategy of bypassing heavily fortified Japanese positions. The after-action reports emphasized an important lesson. Technological superiority alone was insufficient without rapid maintenance and operational readiness. The forward shipyard demonstrated that innovative logistics could multiply the effectiveness of existing forces. Commanders noted that the morale boost among personnel, coupled with tangible results on the battlefield, reinforced the strategic value of integrating engineering directly into combat zones. By late 1944, the consequences of the forward shipyard on Bougainville were evident across the northern Solomons campaign. The rapid turnaround of vessels enabled the U.S. Navy to maintain a near-continuous presence along Japanese-held islands, forcing enemy forces into defensive postures they could not sustain. Destroyers, landing craft, and auxiliary ships that would normally have been sidelined for weeks returned to operational status within days. This not only increased firepower on the front lines, but allowed the Allies to sustain amphibious operations with unprecedented tempo. Strategic reports later described the shipyard as a pivotal node in operational continuity, highlighting the tangible advantage gained by integrating engineering solutions directly into contested territory. The Japanese command recognized the strategic setback. Intercepted communications and intelligence gathered from captured officers revealed a profound underestimation of American engineering capacity. They had anticipated that damaged vessels would be withdrawn to rear area bases in Fiji or New Guinea, creating natural delays in operational cycles. Instead, the Americans bypassed this limitation entirely. The psychological effect on Japanese forces was severe. Frontline soldiers reported increased anxiety, knowing that U.S. reinforcements and repairs were arriving faster than expected. eroding their confidence and undermining the credibility of counterattacks. For the Marines and Navy personnel stationed at Bougainville, the forward shipyard represented more than efficiency. It was a tangible reassurance amid the chaos of jungle warfare. Units previously constrained by equipment shortages found themselves equipped, repaired, and ready for redeployment within days. Medical units observed a reduction in mission delays caused by damaged transport and supply vessels, while artillery teams reported uninterrupted fire support from both repaired naval guns and land-based artillery pieces. These operational improvements contributed directly to the stabilization of American beachheads, allowing forces to consolidate gains and expand control over the island. Casualty reports and operational logs further demonstrated the value of the shipyard. The probability of mission failure due to equipment downtime decreased significantly. Marines recorded that armored vehicles damaged during initial engagements were restored to combat-ready condition in half the time previously required. Similarly, the Navy documented rapid repairs of landing craft essential for troop movement and logistics. These restored assets enabled repeated amphibious assaults with minimal loss of momentum, illustrating how frontline repair capabilities could directly influence the outcome of ongoing operations. Beyond immediate tactical gains, the forward shipyard influenced broader Allied strategy. Military planners began advocating for similar forward-deployed maintenance and repair facilities across the Pacific theater. The lessons from Bougainville were applied to subsequent campaigns in the Philippines, Leyte Gulf, and Okinawa. Logistics officers emphasized the integration of engineering units with combat formations, noting that rapid asset recovery could significantly enhance operational tempo and reduce attrition. Historical analyses later credited the Bougainville shipyard with establishing a new standard for forward logistics, a combination of ingenuity, discipline, and adaptability that reshaped Pacific warfare. The human element also remained critical. Seabees, engineers, and maintenance crews operated under extreme conditions: torrential rains, sweltering heat, dense jungle foliage, and intermittent Japanese sniper fire. Yet their perseverance ensured continuity of operations. Eyewitness reports described teams repairing tank turrets under open skies, welding hull breaches on small craft, and improvising solutions for vehicles trapped in mud or jungle terrain. These accounts reinforced the dual narrative of tactical innovation and human resilience, emphasizing that the success of the forward shipyard rested as much on people as on equipment. By 1945, the strategic consequences were evident. The Northern Solomons campaign had advanced with minimal disruption from equipment failures, and the pressure exerted on Japanese garrisons contributed to the isolation of Rabaul, neutralizing one of the empire's most significant bases without a direct assault. Analysts later observed that forward repair facilities had allowed the Allies to maintain sustained operations over vast distances, a feat previously thought impossible in the remote, jungle-bound Pacific Islands. Ultimately, the Bougainville forward shipyard demonstrated that war was no longer determined solely by combat tactics or firepower. The ability to repair, redeploy, and maintain equipment directly at the front became a force multiplier, ensuring that operational momentum could be maintained despite the harshest environmental and tactical challenges. Commanders and historians alike recognize that the campaign's success was as much a triumph of logistics and engineering ingenuity as of combat strategy. The Bougainville forward shipyard stands as a testament to the often overlooked dimension of warfare, logistics and ingenuity in the face of extreme adversity. Amid the dense jungles, sweltering heat, and constant threat of enemy fire, American engineers, Seabees, and naval personnel transformed a precarious shoreline into a hub of operational resilience. Their work blurred the line between combat and construction, proving that adaptability could rival firepower in determining outcomes. This campaign demonstrated a profound truth about human and organizational capacity in war. Soldiers and sailors could fight bravely, But without functioning ships, landing craft, and vehicles, their victories would be fleeting. The rapid repair of vessels allowed the U.S. Navy to sustain amphibious operations at a tempo that overwhelmed Japanese defenses. In doing so, the forward shipyard became a quiet but decisive actor, shifting the balance of power not through guns, but through ingenuity, discipline, and sweat. Equally significant was the psychological effect on both sides. For Allied forces, it fostered confidence, knowing that damaged assets would return to service swiftly and reliably. For the Japanese, it was demoralizing. The expected delays, logistical weaknesses, and vulnerabilities that should have slowed the Allies were nullified. The forward shipyard transformed uncertainty into certainty, allowing planners to execute complex operations with precision and consistency. In historical terms, the Bougainville experience reshaped the understanding of warfare in the Pacific. It demonstrated that frontline engineering and rapid logistical solutions were as critical as strategy, firepower, or intelligence. Subsequent campaigns across the Pacific borrowed directly from these lessons, embedding forward repair facilities into operational doctrine and changing the way the U.S. projected power across vast distances. Ultimately, the story of Bougainville is not merely about ships, engines, or tactical advantage. It is about human resolve and the capacity to turn environmental hardship into opportunity. It illustrates that in war, innovation often emerges in the spaces between battles, where engineers and combatants alike confront obstacles that seem insurmountable. Here, on a small jungle island, the combination of foresight, skill, and determination ensured that the tide of war flowed in favor of those who could imagine solutions faster than their adversaries. The forward shipyard on Bougainville reminds us that even amid conflict's chaos, human ingenuity can carve a path to victory, quietly redefining the rules of engagement.